In this section, we will continue talking about simplifying radicals. We will focus today on a radical. Instead of written here with the radical symbol, we're going to write it with a rational exponent. Rational really just means fraction. So if you have rational exponents, we're talking about exponents that are written in fraction form. All right, so what we have here, this little number, remember normally if you don't see a number written there, it's like an understood 2. Because the square root is so common, we usually just don't even write the 2. That number right there is called the index of the radical. So whenever you have a radical of index whatever, if you don't see it again, it's a 2, you can always rewrite that as x to the power 1 over the index. Okay? And in fact, if you have the nth root of x to the m, that could be written as x to the m over n. So remember, the index goes in the denominator. So it goes in the denominator of the exponent. So if there's no exponent, remember it's like an understood 1. If you do have an exponent underneath here, you can just put it in the numerator. All right, and then we are going to need these exponent rules in order to simplify some of these expressions. So just remember that when you're multiplying two expressions together that have the same base, you can just add the exponents. So that's because, like, if you have, say, if this was x squared and x cubed, so x squared times x cubed, for instance, that would be 2 factors of x, like x times 3 more factors of x times x times x. That would be 5 factors of x altogether, right? So you just add those exponents. Here, when you're doing x to the a divided by x to the b, you subtract the exponents. That's really because you can cancel out common factors. So if you have a factors of x on the top and b factors at the bottom, then you can like cancel out b of those, and then you'll have, how many factors will you have left? Well, a minus b factors will be left. All right, so now if you're when you're raising a power to a power, suppose this was like x squared cubed. What would that be? That would be like x squared times itself 3 times. So how many factors of x do you have altogether? We've got 2 factors, 2, 4, 6 factors of x altogether. And you can get that by just multiplying those 2 exponents together. So when you're raising a power to a power, multiply the exponents. Also, it's important to recognize what to do when you have a negative exponent. That doesn't say anything about the number itself being negative. When you have a negative exponent, that tells you to take the reciprocal of the base. So here, x to the negative a, the base is whatever this x is. And you could even write that as like 1 over x to the 8th power. So again, a negative exponent tells you to flip the base number, okay? All right, so now that we have all of that clear, let's do a couple of examples. This first one, 36x cubed to the power 1/2. Okay, well, so what does that mean? Well, the 1/2 power here is, we'll do 36 to the 1/2 power times x to the 3rd to the 1/2 power. Remember, when we take powers to powers, you have to multiply the exponents. Think of this as like 3 over 1. What's 3 over 1 times 1 over 2? Just multiply. 3 times 1 is 3. 1 times 2 is 2. So this becomes 36 to the 1/2 times x to the 3/2 power. Now, let's see if I can evaluate this. Remember what 1/2, the exponent 1/2 means. This means the square root of 36. It's an index to the denominator, tells you the index of the radical. Okay, and the square root of 36 is just 6. So this will be 6x to the 3/2 power. Okay? And we're going to leave it in rational exponent form just because it was given to us in rational exponent form. All right, let's do problem number 2. X to the 2/3 power raised to the 2/3 power. So remember, when you're raising powers to powers, you multiply those exponents. So this will be like x to the 2/3 times 2/3. You multiply those exponents together. So that'll be x to the 4/9. Can't think of any way to simplify that. Let's do another one. 27/8 to the power 2/3. So just here you've got a numerator and a denominator for the exponent. Here's my tip. It usually works a little bit better or a little bit quicker if you take the radical first and then the power. So here's what I mean by that. So first of all, 27/8 to the 2/3 power, I can't reduce that fraction. And when you're raising a fraction like this to the power, that's like the numerator to that power over the denominator to that power. Okay, now what I want to do is write these as a radical. So again, the denominator is the index, and the numerator is the power. So you can rewrite this as 27, the 3rd root of 27, and after I compute that, I'll go ahead and raise it to the power. All right, and in my denominator, I have the same thing. 8 to the 2/3 power, the denominator tells us the index. So it's the 3rd root of 8. And then the numerator here tells us the power. So after I'm done doing that computation, I'll go ahead and raise it to the power 2. All right, 3rd root of 27. 3 times 3 times 3 gives me 27. So the cube root of 27 is 3. And then I'll have to square it. Over the 3rd root of 8 is 2. And then I'll have to square that. So lastly, 3 squared is 9 over 2 squared is 4. This problem seemed like it took a long time, but it's just kind of the first time explaining this, that when you have this exponent here that's a fraction, first do the root. The denominator tells you the index of the root, so I'll take 27, the 3rd root of 27, and then raise it to the power 2. You can also check that on your calculator by taking 27 and raising it to the power 2/3. All right, let's do this last problem on the page. Here I've got x to the negative 1/2 times y to the 1/2 times z to the negative 2/3, all of that raised to the 1/2 power. All right, so here's what we're going to do. Remember that when you're multiplying factors and raising that to some power, each factor gets raised to that power. So this will be like x to the negative 1/2 to the power 1/2. So raising powers to powers, you multiply those exponents, times y to the 1/2 power times 1/2. So raising y to the 1/2 to the 1/2 power, so you multiply those exponents. And then times z to the negative 2/3 power to the 1/2 power. So go ahead and multiply those exponents, negative 2/3 times 1/2. It looks like you're distributing this exponent over the multiplication that's happening here. And that is what we see. Let's go ahead and simplify. I've got x to the 1/2 times 1/2 is 1/4. So x to the negative 1/4 times y to the 1/4 power times z to the negative 2 times 1 is 2. 3 times 2 is 6. And you can simplify that to 1/3. One more time. So x to the negative 1/4 times y to the positive 1/4 times z to the 1/3 power. Okay. Oh, negative 1/3 power. All right, now what I want you to see is that the factor of x has a negative exponent, and the factor of z has a negative exponent. So what I'm going to do is take the reciprocal of the base for all of those negative exponent numbers. So it'll be like 1 over x to the 1/4 power. 1 over z to the 1/3 power. But now this whole expression here is going to turn into a fraction. Y will stay in the numerator, and the factors of x and z will go in the denominator. So what I have is y to the 1/4 power in the numerator over x to the 1/4 power times z to the 1/3 power in the denominator. So again, negative exponents those tell you to take the reciprocal or flip the base or put those factors in the denominator. The base x and z are factors in the denominator. So, and then again, once you do that, once you take the reciprocal, put those factors in the denominator, then those exponents become positive. Okay?